Hello, today we'll be going over divisibility rules from 1 to 10. So let's start at 1. So divisibility of 1 by 1, all numbers have 1 as a factor, therefore all numbers are divisible by 1. It's the most simple one out of all of these. Divisibility by 2. Any number ending in 2, 4, 6, or 8 is divisible by 2. This is because 5 times 2 is 10, and any number AB can be written as 10 times A plus B. Note when I'm saying AB here, I mean each of these are digits, or at least for A, it's a combination of digits. And because 10 is a multiple of 2, as long as B is a multiple of 2, AB is divisible by 2. Okay? Let's do divisibility by 3. The sum of the digits equals a multiple of 3. The number is a multiple of 3. So we can start off by proving that 9 is divisible by 3. It equals 3. And also, any number of 9s is also divisible by 3. And the clever thing that we do here, so we rewrite this out as its core form: 1000 times A plus 100 times B plus 10 times C plus D, and so on. You can expand this out that way for as much as you want. This all equals 999 plus 1 times A. Note I'm just minusing it by 1 and then adding 1 as well. So this equals 1000 times A, 100 times B, 10 times C plus D. And finally, we just separate the two. So it's just 999 times A plus 99 times B plus 9 times C equals the sum of the digits. Since the first part is divisible by 3, if the second part is divisible by 3, the whole thing is divisible by 3. Divisibility by 4. This just works the same way as divisibility by 2. Let's go back to that. This is just 5 times 2 is 10. Here we use the fact that 25 times 4 is 100. So as long as we know that the last two digits is a multiple of 4, the whole thing is divisible by 4. Okay, divisibility by 5. Any number ending in 5 or 0 is divisible by 5. We just use the same proof that we used for 2, except we do 5 times 2 is 10 instead. And then we just show that even if we know that 10 is a multiple of 5, as long as B is a multiple of 5, which means it needs to be 1 or 0, 5 or 0, AB is divisible by 5. Divisibility by 6. There's no real rule for this, but anything that has two distinct factors, you can just prove it like this. If it's divisible by 3 and it's divisible by 2, then the whole thing is divisible by 6. The fun one of the day, divisibility by 7. So what you do is you subtract the last digit. You multiply the last digit by 2, and you subtract it from the rest of the number. So if that thing is divisible by 7, the whole thing is divisible by 7. So this one has two parts. This is part 1. So first we're just proving that you can convert this if this is equal to 7 times k, where k is an integer. You can do math to it. What we do here is we minus both sides by 21b. We can factor it out, and since 10 is not divisible by 7, and these two equal each other, a minus 2b has to be divisible by 7. And this only works, by the way, this doesn't even apply for all numbers. This only applies when 10a plus b is divisible by 7. And the second part is where we prove the opposite. A minus 2b equals 7k. So this is what we're saying. We take the first set of we take the last digit, multiply by 2, subtract it from the rest, and that should equal a number times 7. So we do more math to it, multiply both sides by 10, then add 21b to both sides, factor it out, and we now show that 10a plus b is indeed a multiple of 7, as shown here. So that was the fun one of the day. Divisibility by 8 works the same as 2, 5, and 4, except we just switch it out for 1,000, because now we use the fact that 125 times 8 is 1,000. So you can write all numbers like this. We have divisibility by 9. If the sum of the digits is divisible by 9, the whole number is divisible by 9. I mean, you can just look at the easy proof. The number divided by 3 is divisible by 3. The whole thing is divisible by 9. The fun one that I wanted to show today is the modular arithmetic one. So what modular arithmetic is, it's clock arithmetic. You have a circle of numbers, and instead of going like from 9 to 10 and then to 11, where you switch from 1 digit to 2 digits, you just cycle around. So you go from, we were doing mod 10, we would go from 9 to 0, and then go back to 1, 2, 3, 4, 5, 6, 7, 8, 9. So what this is showing is we have a number n, which is divisible by 9. That's what it means by 0. The modulo means that when you divide by 9, its remainder is 0. We just expand that out. A0, A1 times 10 plus A2 times 10 squared, and so on. So this whole thing equals 0. Now, one fact that we use is that multiplication still works the same way in mod 9. So we just show that 10 is congruent to 1 in modular arithmetic base 9. So we just show that all of this is just equal to 1, 1, 1. And then we just remove the 1 because it's redundant. And we just show that it equals the sum of the digits. As long as the sum of the digits is equal to 9, is not equal but divisible by 9, the whole thing is divisible by 9. And finally, we have divisibility by 10. If the number ends with a 0, it's divisible by 0. Much rather simple proof. You prove that first we start off AB equals 10A plus B. We just show that 10A plus B equals 10K. If B equals 0, then we don't include this, and we just have 10A equals 10K, which is divisible, which proves that it's divisible by 10. Therefore, if B is 0, then AB is divisible by 10. Okay? I hope you enjoyed this short video about divisibility rules. If you need help in math, you can go through this channel, subscribe and like, and hopefully you'll find something there that you can use to help understand the topic. Okay, see you soon.